Sometimes things go wrong, and as humans, we very often respond with panicking. Operating systems are no different. They can also panic when things go wrong. In IT terms, this is often called a kernel panic. Different kernels and operating systems have different methods to indicate kernel panic and how they respond to errors. Okay, so why do we get errors? If you cast your mind back to kernels and drivers, you will remember that a kernel always runs in memory, and that drivers are used to extend or add support to a kernel for new hardware. Most commonly, an error will occur when the machine runs out of free memory or if the driver and kernel interaction conflicts with another driver-kernel interaction. This could be due to memory errors, either physical or software simply conflicting and trying to address the same memory space due to bad programming or a programming error. Typically, when a machine suddenly reboots or shuts down, it is an hardware error. It's usually a bad power supply or other corrupted components. And the only fix there is to replace the faulty hardware. The other reason why a machine can suddenly reboot, and sometimes it gives you an error code before doing so, sometimes it does not, is due to the above mentioned software conflict. And a simple way for the OS to clear software conflicts is to reboot the machine. Why is it a simple way to do so? Well, if you think back to system memory or RAM, it is also called volatile memory. So cutting power to RAM clears it. And by rebooting or shutting down the machine, the OS is trying to clear potentially conflicting memory issues. Sometimes this means that the drivers or conflicting software might load in a different boot order, and then the issue with the conflict might be resolved. This is not always the case though. So let's have a look at how Windows and how Linux handles this. First up, let's look at the classic Windows blue screen of death. Typically, the blue screen of death is caused by hardware issues, either physical faults or driver-related faults. Since drivers are added to the kernel, this can cause serious issues when things go wrong. Rarely, it can also be caused by the Windows kernel having low-level software faults. The blue screen of death occurred when Windows experiences something called a stop error. This critical failure crashes the entire OS and forces it to reboot in the attempt to clear it. This can lead to the loss of data, as the application or program might not have had the time to save. Windows will create a mini dump file to store information related to this crash. This file can be useful to try and troubleshoot the causes of the issue. Blue screens also look different depending on the version of Windows that you're running. Windows 7 and older versions had the classic screen, like we just saw, that will give the administrator or end user a good indicator of what problem it can be by stating the code right there on the page. Or Windows 8 and above have gone a different route, and they will display this kind of screen with simply saying something went wrong and then giving you a QR code to scan to find out what was wrong on the website. And then obviously the stop code, because you need that for troubleshooting. It will also try and auto-resolve the issue by rebooting and recompiling. If this fails, then the end user needs to go into the error logs and work out what went wrong and figure out how to fix it. This is the typical location for the Windows 10 mini dump. There are really some fantastic videos in the written content on how to troubleshoot all kinds of errors and the whole process. So I suggest you really make good use of them. Linux and other Unix-based systems are far less prone to the blue screen of death. In fact, they don't get a blue screen at all. They get a kernel panic screen like this one. This is very rare and is usually only caused or triggered by hardware issues. And remember, a hardware issue can be physically, there's something wrong, or a driver causing some problems. Unix have another thing that they call a kernel oops. In this case, the kernel normally continues to run after killing the offending processes. So it will just kill the process that is causing the issue, the oops. But as an oops can cause some subsystems or resources to become unavailable, they can lead to a full kernel panic later. You will get to read and explore log files in more detail in the Linux course. And as with the Windows error reporting, be sure to make use of LinkedIn and the other resources available. Last but not least, we get to an Apple panic. Now, Apple operating systems are not immune to kernel panics either. The most common causes for kernel panics in Mac, iOS, and iPad OS are very similar since they all share the same kernel. These causes usually fall in the following categories. It's either a firmware bug or corruption. It is maybe an OS kernel code bug. It could be third-party hardware or software compatibility issues, or hardware failure, typically related to memory or storage or the actual logic board becoming corrupted. Kernel panics are very rare in modern Apple devices, and it usually only happens on beta software. If you do have a kernel panic, you can go and look for the logs in this location, library logs, diagnostic reports, and that will tell you exactly what you need to know, what caused it, and maybe you can then contact Apple and they can help you sort it out. And this brings us to basic troubleshooting. The blue screen of death or the Linux kernel panic is the most extreme error handling method an operating system can use to attempt to resolve an issue or to inform the end user that there is a serious issue. Most applications or programs will simply close, unload from memory, and try and reload to attempt to run when the problem has passed or when the memory conditions have improved. Often these errors are due to software faults or bugs that the developer will patch to prevent them from happening. Modern operating systems will also attempt to take steps to prevent the program or programs from causing physical harm to the hardware. Now, physical harm can happen when this device maybe gets too hot. And a good example of this is found in consoles like the PS4 or Xbox One, where the system will shut down when a game bug might cause the system to overheat. Actual environmental heat also triggers the same response. This is most noticeable in laptops, notebooks, and mobile devices, where you will feel the device to get warm and the fan suddenly starting to spin like crazy, and then it all feels like it's slowing down. This is the operating system trying to throttle back the processor or the graphics card to reduce system heat to preserve the hardware of the machine. So it's important also that you have good airflow and a dust-free environment to operate your equipment. Dust can build up on internal fans and vents, causing them to perform suboptimally and in extreme cases to actually harm the device. Troubleshooting errors are a large part of the day-to-day operations of any IT technician. So let's have a look at some of the basic things you need to keep in mind when you troubleshoot. Also keep in mind that at this level, you are expected to sharpen your own troubleshooting and problem-solving skills. As such, if you encounter any technical challenges or issues, you are expected to use basic troubleshooting steps yourself before asking for help. Some of these steps, or the most critical ones, are to read, to search, hit the logs, or ask. Read, always read the error screen carefully. Usually it will tell you exactly what went wrong. If it's a bit cryptic, you can search. Use one or more web browser to research the error or find solutions. I recommend not using the same search engine all the time. So maybe use Google and DuckDuckGo since they will give different results. But always remember step one, read. Don't just read the top hit or comment on a forum. Read every comment to see if the fix is really the fix for you. Step three, hit the logs. When in doubt, find the log files and start with step one again. And that brings us to the last step, which is ask. If you still cannot solve the issue, you may ask for assistance from other students or from teaching staff. When doing so, though, remember the lessons from PBL. Provide specific details of the error, the specific error code, what instructions were followed to get to that error code, every detail of your troubleshooting steps up to that point, including the URLs to solutions that you have attempted, and screenshots and even videos. We need to know exactly what you've tried to see where we can assist you. And that brings us to the end of OFS.